My name is Mustafa Hasanalian. I am assistant professor in the mechanical engineering department at New Mexico Tech. I mainly teach aerospace courses like aerodynamic, introduction to unmanned aerial systems, and aircraft design. So I am doing research on autonomous systems, specifically drones, and also on bio-inspiration, biomimetics, that how we can inspire from the nature to design optimized robotic systems. Welcome to the Autonomous Flight and Aquatic System Laboratory. So this is my research lab, and my undergrad and graduate students are actually doing their experiments, and they are making drones in this lab. So these two posters that you can see, they are a design flowchart of the flapping wing drones and the T-rotor micro vehicles. So through this, the students actually will follow this step in order to design and manufacture some optimized drones. So in this part of the lab, we have different type of electronic equipment. So in order to manufacture the drones, we need to have some parts like electric motors, like LiPo batteries, different type of remote controller, battery chargers, servo motors, different types of propellers, and also some material that we are using for the structural part of the drone. So in order to manufacture the drone, one of the major equipment is 3D printers. So in my lab, I have two 3D printers here that my students are applying to manufacture and 3D print different parts of the drones. Drone have 200 applications, so but we are not using them in our daily life. So one of the projects that actually we are doing here in my lab is designing a smart city. So making some concepts that everybody can use drones for different types of applications. So imagine that someone has a heart attack in the street and they need some medicine to be delivered. Or for example, a police is chasing a car and is stuck in the traffic, and they want to monitor those type of crime. So what we are doing here is designing a smart concepts that these drones, they can implement it into the city to be used for different types of missions. So one of the concepts that we have here, drones have usually a low endurance, so they cannot fly for example, no longer than 20 minutes like these multi-rotors. So one of the projects that we are doing here is designing a system that can replace the battery of the drone. So these drones would be able to fly in the city, they can land in their station, and they can switch the battery and continue the mission. So a part of my research is bio-inspiration and biomimetics, that how we can inspire from the nature to design optimized drones. So one type of the drones are flapping wing. We have 8,900 species of birds that they have different characteristics. So in my research group, we are actually inspiring from the birds to design some optimized flapping wing drones. So for example, we can inspire from the shape of the wing of the birds to implement, to design the wing of these flapping wings. Or for example, in a smaller size, we have the insects and we have the butterflies that we can get inspiration from their flight modes, from the shape of the wing, from their flight characteristics, in order to design some tiny flapping wing drones. So before manufacturing any type of the drones or aircraft, we need to run different types of analysis. So one of the tools that we can use is using some open source free software. So this software is called XFLR5. This is an open source software that we can use to do the aerodynamic modeling of our design. So I usually teach this type of software in aerospace courses that I'm teaching at New Mexico Tech. So here, what we have done as an example, we have modeled the whole aircraft, and we can run different types of aerodynamic analyses. So here we can see the pressure distribution, the lift distribution, and also the different types of drag design. So we can change the angle of attack, and we can see that how these aerodynamic forces are changing with changing the angle of attack. We also can do a flow simulation, so I can show it here. So we are going to just keep the pressure coefficient and also apply streamlines, so we can see here in different views that how the flow would move over the aircraft. So these are some vortices that we can see here that they have been generated in the wing tip of the aircraft, and here we can see that how the lift would change with changing the angle of attack. Also in this part of the software we can see the aerodynamic coefficients based on the angle of attack or different parameters. We can make a graph out of that. So after performing this type of the simulation, students would be able to start the manufacturing, because here they can actually verify their design with running this type of analysis, and finally start the fabrication process of this type of fixed wing drones. So the structural part of this drone is consisted of a fuselage, a wing as the main part of the drone, a vertical tail which acts for the lateral stability, and the control surfaces. So for the electronic part, we have a brushless electric motor, we have a propeller here that acts to generate the thrust for the forward flight, and also we have two servo motors that they are acting as the actuator for these control surfaces, so they can change the angle in order to take off or land, or for loitering flight. And also the rest of the equipment, including the batteries, autopilot system and receiver, they all go inside the fuselage. So the shape and the size of all these components is so important to fit all the electronic equipment inside the drone. Another type of the drones are multi-rotors. We are seeing this type of drones including quadcopter and hexacopter in our daily life, but this concept is a little bit different. So this is a spherical drones that we have designed and manufactured for inspection the underground mines. So we know that in the underground mines we don't have any light, it's a GPS denied environment. So this concept has been designed in such a way that can fly safe in those harsh conditions and can do different types of mission. This drone is composed of different parts. So the first part is the base of the drones, which is a quadcopter with the 4 motors and 4 propellers, and also all the equipment including the autopilot system, receiver and the battery. But our novelty is designing this cage that would protect these drones to fly in the indoor spaces. So in order to design this cage, we have used 150 carbon rods that they have a very lightweight, and they can protect, and they can make this cage, and they can protect the drones for any type of the hazards that we can have in indoor spaces.